Okay, we're going to be finishing up section 11.2 with looking at possible rational zeros. But before we start looking at the problems from the book, we need to go back and look at just a simple factoring problem because we're going to be using some concepts from here that are going to relate to what we're talking about in today's lesson. I actually want to start off looking at the answer here of x equals 3/2. And I want us to concentrate on this denominator of 2 and sort of track it backwards up through my problem. Well, a step above that, I see it's the coefficient of the x term, and it stays that way up until I get to these set of parentheses. Likewise, over here with the 5, this 5 that's in the denominator tracks back up through my problem, and it is the coefficient of this x term. As you can see, I have all of the 2's written out in pink and all of the 5's written out in pink. So these two denominators of 2 and 5 go back to the coefficients up here for 2x and 5x. Where did the 2 and the 5 come from? Well, they came from this 10. Okay, so you can see now that I have the 10 highlighted in pink as well. So this 10 that we start with gets split into 2 and 5, and they eventually end up as my denominators down here in my final answer. Well, now let's look at the numerators of 3 and 4. You can see that in this first answer here on the left, x equals 3/2, the 3 was the constant all the way up through the problem. And on the right-hand side, the 4 was my constant all the way up. Okay, so we have our 3 and our 4 tracking back up through the problem, and we can see that the numerators here in my final answer actually came from being a factor of the constant over here of 12. All right, so we can kind of come up with a general rule here for what's going to happen with these problems, is that my answers are always going to have factors of the constant as my numerator and factors of my leading coefficient for the denominator. Now the constant is this number 12 out here. Constant means it's always the same, so there's no variable associated with it. And the leading coefficient is the coefficient of your biggest degree. So in this case, it's 10. So my numerators are the factors of the constant, 3 and 4, or factors of 12. And in the denominator, I have factors of my leading coefficient, 2 and 5. Now let's go back to the factor tree that we had been talking about earlier. In elementary school, you learn how to do a problem like this on the left-hand side of the screen by knowing some of your divisibility rules to figure out where to start. In the problems we were looking at in our last section, we had been given the 0 to tell us where to start with, or given a factor to help us sort of get started on our factor tree. But what if we have a problem where I'm not given any starting information? Let's look at this problem, for example. If I wanted to find the factors of this polynomial and I'm not given a place to start, what do I do? Well, that's where that information comes in from up here. I know that the numerator are factors of the constant, and I know that the denominators are factors of my leading coefficient. Okay, so let's look at factors of my constant, which is this 15. What numbers can go into 15? Well, 1, 3, 5, and 15. And also -1, -3, -5, -15. So I have positive or negative of all of those. Now let's look at my denominator. The factors of my leading coefficient, which is this 4. So what factors do I have for 4? Well, I've got 1, 2, and 4. And again, I have positive and negative of all of those. So the way that I figure out all of my possible rational zeros is to pair each one of these numbers in the denominator with each one of them in the numerator. So let's start with this 1 right here. I'm going to write that down as my numerator, and I'm going to pair it up with all three denominators. 1 over 1, 1 over 2, 1 over 4. Now I'm going to do the same thing with the 3. 3 over 1, 3 over 2, 3 over 4. Now I'm going to do the same thing with the 5. 5 over 1, 5 over 2, 5 over 4. And then with the 15. Now those are all of my possible answers, except for I want to be sure I have positive and negative of all of these. And I also want to simplify these first numbers here. 1 over 1 I can simplify as 1, 3 over 1 is 3, 5 over 1 is 5, 15 over 1 is 15. Okay, so now I've substituted those numbers in after I've simplified. The next thing I need to do is go back and be sure I have all of these marked with positive and negatives. Okay, so those are all of my possible rational answers. And I do need to point out before I forget that every once in a while in my math lab, when you see these answers, they're going to be multiple choice and you just have to click on the right one. Every once in a while, you will see a number that is repeated. So just sort of ignore that and just say that that's the right answer. Another thing about the answers in my math lab is that all these numbers here for your answer are not necessarily going to be in order. Okay, well now that just gives me really the first half of my problem. If my goal is to factor this function f of x, then I haven't really finished what I started off to do. I found possible factors, so I could divide my polynomial by each one of these factors until I found a value that would give me zeros. Then I know that that number is a zero of my function. So from there, I could figure out my factor. And that's kind of how my math lab tells you to do. It says to just guess and check all of those answers until you find one that works. I think using that method is very time consuming. So what I suggest you do is to take this function that you have here and put it in your calculator under the y equals function, and then look at your table. Okay, so when I put my function in the calculator and look at the table, I am looking for a y value of 0. And one of the numbers that I can find in my table is a -5. So now I know a 0 for this function. I can use the ideas of what I did in my last section to start factoring my polynomial. Okay, so here's what I have so far. I know that -5 is a 0 of this function. That means I have x plus 5 as a factor. So I'm going to use synthetic division to divide this. And you can see I get 0 over here for my remainder, as it should be. So this quotient is going to be 4x squared minus 4x minus 3. So from here I have to factor. This is not something that factors easily. So you multiply your leading coefficient times the constant, you get -12. What multiplies to give me -12 adds to give me -4. It's -6 and +2, so I factor from there. So my other factors here are going to be 2x minus 3 and 2x plus 1. And my zeros, I find by setting these factors equal to 0. and solve. So my other zeros are 3/2 and -1/2. Okay, so I have my zeros and my factors up here. And depending on exactly how the question is worded, I may need to go ahead and write this out as f of x equals x plus 5 times 2x minus 3 times 2x plus 1. Okay, with this problem, I want to find my possible rational zeros. What I want to do is find the factors of the constant, which I have written out in blue, and factors of the leading coefficient, which is in pink. So the factors of the constant are 1, 2, 3, 4, 6, and 12. The factors of the leading coefficient are 1, 2, 3, and 6. And I have positive and negative for both of those. I'm going to start with this one that I have highlighted, and I'm going to pair it up with each one of these numbers that's in the denominator. So I have 1 over 1, which is 1. Then I have 1 over 2, 1 over 3, and 1 over 6. Now I'm going to move on to the 2 that's in the numerator and pair it up with each one of the numbers in the denominator. So I have 2 over 1, and that's 2. 2 over 2 is 1. And I have 2 over 3. And then I have 2 over 6. And 2 over 6 will simplify to 1/3. Then I'm going to pair up this 3 with each one of the numbers that's in the denominator. So I have 3 over 1, which is 3. And I have 3 over 2. I have 3 over 3, which is 1. And then I have 3 over 6, which is 1/2. Now move on to the 4. So I have 4 over 1, which is 4. And I have 4 over 2, which is 2. I have 4/3. And then I have 4 over 6, which simplifies to 2/3. Then we move on to the 6. 6 over 1 is 6. 6 divided by 2 is 3. 6 divided by 3 is 2. And 6 divided by 6 is 1. And then our last number, 12. 12 over 1. 12 over 2. 12 divided by 3. And then 12 divided by 6. So those are all of my positive values. I would also need to take the negatives of those. But notice I also have a lot of these that are repeating. So I'm just going to kind of clean all of that up. Okay, and there are all of my possible rational zeros.